Welcome to the video on loads on the building. In this video, you will learn about the loads a structure is subjected to, the loads specific to tall buildings, and the standard codes followed for load calculation and structural design. A structure is subjected to different kinds of loads, all of which may or may not be applicable to the same structure at the same time. The major types of loads are mentioned below. The gravity loads are dead load, which is the load due to the self-weight of the structural members and their materials. Live or imposed load, which is the movable load, due to the people occupying a building or its furniture. The snow load is the downward force on a building's roof by the weight of accumulated snow and ice. The major lateral loads, that are the loads acting horizontally, are wind load is the force on a structure, arising from the impact of wind on it. Seismic load, which is the force on a structure, due to a surrounding earthquake. There is also another type of load, called straining load, which is responsible for causing strain in the structural elements. The loads considered under straining loads are: the change of the temperature in the structural and non-structural members, causes thermal stress in them, and is defined as the effect of temperature load. Shrinkage, an effect in concrete structures, is the contracting of a hardened concrete mixture, due to the loss of capillary water. This shrinkage causes an increase in tensile stress, which may lead to cracking, internal warping, and external deflection. Creep is also a phenomenon specific to concrete structures, where a concrete member, experiencing a load sustained for a long time, undergoes inelastic deformation, after it has surpassed the limit of elastic deformation. As the loading period increases, this creep increases slowly, at a decreasing rate. The effect of creep is thus noticeable over a long period of time. Foundation settlement is the sinking of the foundation inside the soil, which results in the sinking of the entire building. This occurs if the foundation is not designed strongly enough to complement the bearing capacity of the soil, and might also be due to the structures and foundations in the neighboring area. There are also some loads categorized under special loads. They are moving loads, which are the loads subjected to bridges, roads, railway tracks, etc., where the vehicles give the loads that keep changing the point of application with time. Blast load is the load because of a blast explosion, nearby or within the structure, due to pressure, or bomb, or quarry blasting. These cause catastrophic damage to the building structural frame, both externally and internally. Machine handling is the significant amount of extra loads, subject on floors of a structure, due to continuous running of heavy machinery on them, and their resulting vibrations. Let's take a look at the common loads, specific to tall buildings, which are usually considered during their analysis and design. They are dead loads, live loads, hydrostatic and soil loads, snow loads, wind loads, earthquake loads. The dead, live, hydrostatic and soil loads, and the snow loads are considered as static loads, as they do not change over a period of time. The wind and the seismic loads are considered as dynamic loads, as they are not constant over a period of time, and keep on changing. Now, in order to apply these loads onto the building, to perform structural analysis, there are some standard codes that need to be followed for calculating the amount of loads to be considered. These IS codes clearly state the amount of the load of different types to be considered, based on different cases. The IS 875 series is the list of codes to be followed for some of the common loads. Let's take a look at this list. For dead load, you have IS 875, Part 1. For live load, Part 2. Part 3 for wind load. Part 4 for snow load. And finally, the IS 875 Part 5 code lists down the stipulations for calculation of some of the special loads, and the combinations of the above loads. You will be learning about wind load in detail in the next module. Let us take a look at the factors that affect the consideration of dead and live loads, as per the IS code. As per IS 875 Part 1, the dead load to be considered depending on the unit weight of the building materials, as they are the self-weight of the structural elements. For example, the IS code states that brick masonry has a unit weight of 18.8 kN per meter cube, whereas reinforced cement concrete has a unit weight of 24 kN per meter cube. Similarly, the live load in the IS 875 Part 2 depends on the occupancy type. For example, it is stated in the IS code that, for bathrooms and toilets, you need to consider a live load of 2 kN per meter of floor area, which is uniformly distributed, or a concentrated load of 1.8 kN. Likewise, the live load for banking halls, classrooms, X-ray, and operation rooms are to be considered as 3 kN per meter square of uniformly distributed load, or a value of 1.8 kN point load. Although live loads keep changing from time to time, these loads are to be suitably assumed by the structural designer, after referring to the IS code. You will learn the assigning of these loads to the building in the upcoming videos. In the next video, you will learn to model a building in the ETABS software. Thanks for